Can y'all see that? So I got two functions up here. F of c is c squared, and g of c is sine 3c. And I'm going to be asking lots of questions as we go through this. We'll be asking lots of questions, so everyone, jump in. Don't hesitate to answer. Don't make me start calling on people by name. Let's just keep it as a group discussion. Okay, so and so now I'm showing this is what we call R3. R3 is let's see here. So most of your math career, in terms of graphing, has lived in R2. R2 means the real numbers horizontally. Conventionally, we use the variable x, and then the real numbers vertically, and conventionally we use y. And so this is R2. So R3, then, we have x and y, and then we actually lay that down vertically, or sorry, horizontally. We lay down the xy plane horizontally, and then we have a third axis, z, which is vertical, right? So this is the R3 coordinate system. So you've seen this before in Calc 3. And so my first question is, I have a graph here. It's kind of bluish. So you can see it's kind of blue here by the origin, but it's this graph here. And so what does this graph have to do with functions f, g, and variables x, y, and z? So what does the graph that I'm showing you, what does that have to do with function f and or g and or x and or y and or z?
It looks like the curve is f of c drawn in 2 dimensions.
Okay, so you're saying that that curve relates to the function f. The rest of you agree with that?
In the xy plane, yeah.
All right, in the xy plane. You guys agree with that? Okay, so all right, so can we say a little bit more about that? Like, how do x and y then relate to the function f the way that I've graphed it? Somebody else?
F of c is y, and c is x.
Okay, so but what is c here? Right? C is really just a placeholder. It's the way I'm defining the function. I could have written f of b equals b squared. So rather than talk about c, there's really nothing special about c. Just talk about x and y. So what you said is correct, but just talk about x and y. How about? So Donna, can you rephrase that without using c?
So f of x is x squared.
F of x is x squared, right? Okay. So, and what does it have to do with y?
Y equals x squared.
Okay. Right? So putting that all together.
Y equals x squared. Or y equals f of x.
Right, right. So this is showing y. This is showing the function f, where y is the dependent variable and x is the independent variable. The rest of you agree with that? Okay, right, exactly. So I'm showing y is a function of x. This function of x, I'm showing y as this function of x in the plane, in the xy plane. Okay, good. So let's see here. So I got, let's call this x naught. Okay, so this point right here is x naught, and I'm gonna at x naught I'm gonna draw a line up to there. Okay. And I want that length right there. I want to represent that length in as many ways as I can. So what's one way I could represent that length given our functions and variables? What's one way? Somebody knew.
F of x naught.
She wants, is that Yasra?
Yeah.
Yasra wants f of x naught. What do the rest of you think? Is that one way to represent that length? Got nods. Okay, what's another way? Somebody new.
Could you do like an ordered pair? So like x naught, comma, f of x naught.
Okay, so
like,
all right. So in terms of that length right there, with that length, blow this out to this. Is that length represented by an ordered pair?
no, not the length.
You changing your mind?
Yeah.
Yeah. Okay, so if you're focusing on this point, the location of this point, that would be correct what you said. Yeah.
Yeah.
But if we go back to the length of that, what's another way to represent the length?
Why not?
Why not? Yeah, or what, some kind of y value. Good. Any other ways?
X naught squared.
She wants x naught squared. Does that represent that length? Okay, cool. Very good. All right, so now I'm going to show you another graph here. Let's turn off everything I got. Now I want to show you this graph. Okay. And again, I'm going to ask you, and I'm not looking for a definitive, encompassing answer, but just maybe some. Let's just talk about. Oops. What did that happen? The heck. I'm all turned around now. I am totally turned around in my view of this. There we go. I think I'm coming back here. There we go. Okay, sorry. Wow. That's all I wanted to do, was just that, so I could. So when you move it a little bit, you can really see what you're looking at, right? So just a little motion helps you to see what's going on. Okay, so now I don't want an all-encompassing statement. We'll build up to that. But so in terms of, again, same question as before. This is kind of reddish. This is a reddish graph. In terms of the functions f and g and x and y and z, can you tell me something about this graph in terms of functions f and g and x and y and z? But I'm not looking for like the answer, right? So I just want, let's just kind of, what are some elements of that? What's one thing? So we're trying to relate x, y, and or z, f and or g. So can you tell me one thing like that? No one has any idea? So the last one only involved x and y. Does this one involve z? Okay, so Ashley, can you just tell me just something? What do you think z might relate to here?
Maybe like the y, or yeah, because it's now like instead of being flat on the y plane, I guess it's elevated onto the z plane.
Okay. And so, like, is z the independent variable or dependent variable of one of these functions?
Maybe dependent.
Okay. For which function?
G.
G? Okay. So z is dependent function of dependent variable for g. Anything else? What about the independent variable for this graph? Does it relate more to x, more to y, neither? So first of all, is this the graph of g? Is this the graph of g? sine 3c. Sine 3, yes or no? So you
I
can
don't think so.
Why not, Donna?
Because it's on a curve.
Okay, all right. So it's certainly not the R2 version of it.
Yeah.
Okay. So what about, so you can answer either question. Is this the function g? Is it a version of the function g? And also the other question is, what about the independent variable for this? So either question you can, if you have a thought or an idea about that. So does x or y play into this?
Would the independent variable be the function f? Because like g is graphed along the graph of f.
Okay. So that would indicate x or y.
Y.
Okay. So maybe y is the independent variable for g.
Yeah.
Some kind of y value. Any more thoughts or comments about this new graph that I showed you? Okay, so besides the fact that it's graphed on the curve, is there anything else that you would say, oh, it's not looking like sine of 3c to me?
I think at the 0 point,
Okay.
sine usually doesn't bounce back up like that.
Any of the rest of you notice that?
It kind of looks like the c squared or that type of function could be worked into it in a way.
Okay. Okay. All right. So yeah. So it's those are all good comments. So yes, we're gonna think this. So the y value of this graph then is, so this is true. The y is the independent for g, and then we're graphing the dependent variable of g as z, right? We're graphing it vertically. Okay, so maybe we don't. So and we got some other issues here that we kind of mentioned. It's kind of like, what's really going on here? And that's okay. I think that just this is enough to keep going. All right, and then maybe we can make more sense of it as we go. Okay. So the next thing I want to do is I want to get a better rendering of this. Okay, that's good. A little more top view slightly. So this point right here, the intersection right there. So I'm going to trace this back to the x-axis. I'm going to call that value x1. Okay, and so your task is find the value of x1. Knowing what? Knowing this blue curve is showing y as a function of x in the xy plane. The red curve is showing z as the g function of y. Okay, so knowing that, can you find this value x1 right here? And so I want you to make a picture of that. If you can just sketch this much of it, or take a screenshot. So you can work with it. But if you can get that much of an image, either by a sketch or a screenshot to save, I'm going to put you in breakout rooms for about 5 or 10 minutes. See if you can come up with the value of x1. And I truly want a value. I want a number, like, pi over the cube root of 86 plus 3.9 squared. Okay, that's a number. So I truly get a number. What is that value x1? Something like that. Okay, is the task clear? Do you have a rendering of it to save? Because you won't be able to see my screen outside in your breakout room. I got something to share here. Elizabeth, do you want to talk about what you guys did?
Yeah, so we were talking about the idea of since they're intersecting and that like our FFC or like our blue graph is on the xy plane, then our z has to be equal to 0.
Okay, so z is 0. And where'd you go from there?
So, and then doing that, we had to determine like x and y values that were going to like be equal to each other. So you have to like say that our g is based off of our FFC. So like we're expressing that as sine of 3 of FFC. So then you have to find when that is going to be equal to 0.
Okay, and okay. So what do we know about the sine graph being 0? What is so like? It's like we're following the sine graph here. It's 0 at 0, and then it comes back in as 0 again. Where is it 0 again?
And negative pi then.
Okay. Negative pi? That's not what you had. So what are the values of y going into? Are they negative or positive here?
My
Positive.
values are
So
positive.
these are, we said the independent variable for g was y, and these are positive values, right? These are positive values of y. So it's as if we're actually going this way on the sine graph, right? Because the independent variable is actually positive, and that's why the graph is going up instead of down. Does that make sense? So then, therefore, with that in mind, what z equals 0 corresponds to what? It's like the first time it returns to 0, right? Anybody?
When y equals pi.
Right. Now we got to be careful because we don't actually we have sine what? Sine of 3, right? We have sine of 3y, right? So we want y to be pi? What do we want to be pi?
The whole thing to be pi, so we want y to be pi over 3.
Yeah, so what goes, the angle measure that makes sine 0 for the first time is pi. So then we want 3y to be pi. Does this make sense to everybody? So this is sine returning to the 0 for the first time. That means the argument of sine would be pi, but our pi is 3y. So then you said that y is?
Pi over 3.
Pi over 3. Okay, somebody else take over from there. What's our goal? Our goal is to get x.
We can use our first function, so the f function, because we know that f of c equals y.
Uh-huh.
So we have c squared equals pi over 3.
So c squared is pi over 3.
Which is technically x squared equals pi over 3.
Okay, good. And looking at the situation, what do we conclude then? What is the value of x1?
It being negative square root of pi over 3.
She wants negative square root of pi over 3. But the rest of you, what do you think? What about the fact that we said that this is that okay with the fact that we said this is acting like sine in the positive territory? Are we okay with that? Why? Why is that still okay? So x1 is negative. how is it that then that this acts like it's in positive territory over here?
Because now we're in the XY plane and we're
Okay.
not doing the R cubed plane. So
But won't negative x over here, then won't that be like the graph going down? Why does the graph go up?
Because when you square and you the x values, regardless of whether they're positive or negative, the corresponding y value will always be positive.
Right. So it's the y value being positive that makes this effect, that it's like sine is heading to the right, even though we're going to the left. So we are going to the left, negative x, but the fact that, like she said, you're squaring x to make a positive y, and then that positive y results in the graph acting like we're going to the right on sine from 0. Okay. Any questions on that? Pretty cool, huh? Any questions on that? All right, so now I want to do another kind of situation here. How about right here? So that's, I'll try that again. That wasn't great. That's good. Okay, and then x2. So x2 takes me to this point, and then this point. So this is horizontal, and this is vertical. Does that appear that way? Or do I need to change the view? So this is a horizontal segment to the graph of f, and then from the graph of f, vertically up to the graph of g. So I want us to brainstorm as a group. So this vertical segment now, the length of this vertical segment, we want to come up with as many ways as we can to represent that length. So we came up with 3 ways to represent this length before, when I just picked a point like this. Now I want, how many ways can we represent this vertical length based on what we said the relationship of x, y, and z and f and functions f and g are? So anyone got one? So what would be one way to represent that vertical length?
G of f of x sub 2.
G of f of x2. You guys agree with that? Okay, what's another way? Well, I'll tell you right now, there are lots and lots of ways to represent this length. So, can you think of some more?
G of x sub 2 squared.
G of x sub 2 squared. The rest of you agree? Does it work? Okay. What else?
You can say like sine 3 of x2 squared.
Sine of, what is it?
Sine 3 of x2 squared.
3 of or times?
Times.
Like that?
Yeah.
What about the rest of you? Agree with that? Are these all good? Okay, keep going. I used to make this I used to put students in groups and make a contest out of this, see who could get the most, but there are more.
Sine of 3 times f of x sub 2.
Like this?
Perfect.
Okay. What about using y or z? So these are all good ones for just using x2. But what about using y or z?
Sine of 3y.
Sine of 3. And so if we're corresponding to x2, maybe it's sine of 3, what, y2?
Oh, yeah, yeah. Z sub 2.
z2? I know of at least one more. Anyone think see another one?
We just put g of y sub 2.
G of y2. How many we got? 7? Let's see here. 1, 2, 3, 4, 5, 6, 7. Maybe 7 is our limit here. Can anyone think of any others? Maybe that's it. Maybe that's everything. Okay. So really, for x2, so if we can think about for the value x2, that results in some z2, right? So if this is z2, for any given x results in some related z on the red graph, right? So we can look at that right there and then just generalize that, right? So for any x, you're going to get a corresponding z according to y being the deep, y being what you get in f for x, and then z what you get from g from y. So z, all those z values are really g of f of x, are they not? Does that make sense? And so let's go back to that question. Why do we have this weird thing happening? If this is the sine function, sine 3c, why this weirdness here? Why doesn't it go through the way we expect sine to do? Why does it pop up and go positive here?
Because our independent variable for the g of c graph is y, and the y are positive from the f of c graph. So
Yeah.
we're always going to have a positive sine graph.
Yes, exactly, for the sine graph for a positive independent variable, right? So it's like sine going this way, but then now going this way, we're going to get the same thing because our independent variable is y, which is positive, right? So that's why it's doing this weird thing to sine, because we're only ever looking at this half of the graph. See that? We're only ever looking at this half of sine of 3, say 3y. Because the y is positive going this way. So we never really we never get to see this part of it where it goes down first. So it's this way going in positive x territory, but then you get this again going in negative x territory. Okay. Let's erase some stuff here. So we're going to call this a new function, h. So this function, because you give it an x, it gives you back a z. We're going to call that h. I'm going to introduce a new function, h of x, which is what you get when you put x into f and take the result of that and put it into g. So now we have 3 functions now. We have f, and we have g, and we have h. So can we find a formula for h? Is there a formula for h? So can I include, say, h of, say, c? Let's do something else. Just say h of b. Can I write, is there a formula I can write for h of b?
Yeah.
Tell me.
I think it's sine 3 of b squared.
Sine 3.
Or sine of 3b squared.
Sine of 3b squared. What about the rest of you? Agree with that? Okay. So now I got 3 functions. I got f and g and h. And notice here in R3 there are 3 coordinate planes. And tell me, what variables do, let's see, so what variables does f relate? It relates which variables? X, y, and or z? What does f relate?
X and y.
X and y. How can I look at just the x and y plane? What can I do? How should I look at, if I want to, I don't want to see z, I just want to see x and y. What would I do?
Could you just rotate the graph to where you're only looking at the x and y
And
plane?
how would I do that? How do I look at just the x and y plane? What are you thinking?
Like rotate it. I guess it's hard to explain. Like rotate it down, I guess. I don't.
Like the z is facing towards us. Right?
Yeah, that.
So you're looking right down the z-axis?
Yeah.
Okay. And so when I do that, what do you see?
You see the graph of f.
I see only x and y, and the graph of f related x and y, right? What did we say the graph of g related? What was the graph of g? What 2 variables did that relate?
Y and z.
Y and z. How do I look at just y and z?
With the x-axis pointing at us.
Okay. So I'm going to take and look at just the x down the x-axis. and without the spatial, see, oh, I can get it. Yeah, almost. And when I just look at the YZ plane and take X out of the view, maybe, what do you see?
The graph of G.
Just function G, which relates Y and Z, right? So if I just look at if I isolate the view of Y and Z without seeing X, we're just going to see the graph of G because that related what Y to Z. There it is. And we said it's only this half of it because Y is always positive. All right. What about the function H? What does that relate?
X, Y, and Z.
Sine of 3b squared.
Just X and Z.
Just X and Z, right? So when I write it this formula here, it's just taking an X and spitting out the Z, right? How can I see that?
Have the y-axis facing us.
So I'm going to look right at the y-axis, and I get a graph. And what is that the graph of? What should I type in here? Y equals? Sine of 3x squared. Is it the same? So I ended up with these three functions, each one related a pair of x, y, and z. And now I have in each of those views then, in the xy view, I see the function that relates x and y. In the xz view, I see the function that, this is the xz view, I see the function that relates x to z. And then in the yz view, I see the function that relates y to z. That's just the sine 3c, sine of this one. Questions, comments? You see what we're doing? So what's the concept here? What was this conversation all about?
Sounds like function composition.
Right, so this is composition, right? So we've been talking about composition, and this is kind of giving us a visual representation of composition, right? A visual representation using R3. So my question is, which is the composition of F and G? Is it exhibit A, or is it H, or exhibit B? Which one of those is the composition of functions F and G? Oh, I stumped you there. What do you think?
Isn't it both?
What's that?
Isn't it both?
Yazra says both. So if they're both a composition, are they the same or are they different?
I'd say the same, just represented in different ways.
Okay. So if they're the same, how about visually? How can I show that they're represented different ways visually? How do we represent this visually? So this one where we made it just, sine of 3x squared. this version of the composition, like eliminate the middleman, right? So this is the version of composition where it's like middleman is gone. I'll give you the first value and you'll give me the final value. And it becomes like a one-step process, no middleman. How do we see that in R3?
We looked to the XZ plane.
Yeah, just the XZ plane. Take Y out of the picture, right? We're eliminating the middleman. If we want a one-step process, we eliminate Y. That was this one. That's H of X. That's the composition in terms of a one-step process without Y. What about this version? This is also composition. Like Yazzer said, this is also composition, but it's represented differently. Now we're thinking of what? We're thinking of a two-step process. Take the value of X, generate the value of F. Take that value, use G to generate the final value, right? Two-step process. How can I show that visually? What of X, Y, and Z do I need to see?
All of them.
All of them?
Yeah.
So what view shows all of them?
The one you started with.
Yeah, the one that we were working on, right? This one. When you can see all of X, Y, and Z, now we're seeing the H function as the two-step process. And that's why we're saying, here's an X, corresponding Y, finally Z, right? So that shows the middleman. That shows that Y value getting us from X to Z.